Hiya 12, just going to explain example 12 and 13 from chapter 6.7 to just try and go into a bit more depth than the book does. So it says, show that a function fx is increasing for all real values of x. As soon as you see this word increasing or a decreasing function, then just think, differentiate it to see what the gradient function of that looks like. So if I differentiate that, then I get 3x squared plus 24. So as you'll see from the notes in the textbook, if the gradient is always 0 or above, so positive basically, 0 or positive, then it's deemed an increasing function. So we know that x squared is always greater than or equal to 0, because even if you put in the biggest negative number in the world, it will come out positive, or any negative number will come out positive, and any positive number will come out positive. Therefore, 3x squared plus 24x must be greater than, well, it's actually got to be greater than 0 because of that plus 24 bit. Greater than, I haven't deleted the right thing there. Greater than 0 for all values of x. So what does that actually mean? Well, I think it's good for you to, even before you start this question, draw this function in your calculator to see what it looks like. And it does look a bit strange in your calculator, so I've also drawn it on GeoGebra, and it sort of looks like a straight line in this case, but if I press zoom to fit, it's changed my axes slightly, so that it's a bit more clear what it looks like. And you can see now it looks a lot more like a cubic graph. So we know that it looks like a cubic, something like that. What we're saying is that, remember, when we're finding the gradient, we're finding the tangent, or the gradient of the tangent at various points on the graph. So what would my gradient be there? Well, it might be something like 4. What about my gradient here? Again, it's going to be positive, and we can see that wherever I draw my tangent on this graph, even though it gets quite shallow here, it's still going to be positive. So I'll just draw one more. So whatever tangent I draw on, I'm going to get a positive gradient, meaning it's an increasing function. So it's all about looking at what is that gradient across the curve. Any tangent I draw to this graph will have a positive gradient. That's the same as saying it's an increasing function. Right. Let's have a look at example 13 then. Find the interval in which the function fx is decreasing. So function decreasing, they are your key words that you should be thinking, right, let's differentiate that. So if I differentiate that, remember to use your notation, then I get 3x squared plus 6x minus 9. Well, I know from the notes in the textbook that a decreasing function will have a gradient that's less than or equal to 0, so I can set this quadratic less than or equal to 0, and then I'll find the points where my gradient is less than or equal to 0. So first thing I can do is take out a factor of 3 to make it easier for myself, and then we can ignore that 3, then factorise, and then let's just draw that quadratic so we can solve it. So it would look like that. So we're after the bit that's all less than or equal to 0, so that means that x is between minus 3 and positive 1. So that's where this is a decreasing function, because it's all less than, the gradient is less than 0 at all of those points. So again, draw it in your calculator, or I'll draw it on GeoGebra now. So let's delete that. So it was x cubed plus 3x squared minus 9x. Okay, and then I've got my graph. Let's do that shape to fit thing again. Zoom to fit. It hasn't changed it. Okay, let's just zoom in. So let's just put a point on here. So this time I won't draw the. Is that point gone? So we're looking at point D. Why does it keep disappearing? So point E. Really off for some reason. Anyway, our key points that we found were between -3 and +1. So if we imagine drawing a tangent across all of those points, or I'll draw it on my other file here. So we saw that the graph looks something like, let's try another. So it was a cubit. That looked something like that, and this point here was 1, and this point here was -3. So we're saying that if I draw a tangent anywhere between those points, my gradient will be negative. So a tangent there, it's very shallow, but it is slightly negative. Gradient there, it's much more negative. Right up to 1, where it would be flat line, but anything before that, my gradient's negative. So decreasing function just means that your gradient is negative between those points. Right, I hope that video helped. Have a great rest of your day.